Thank you for coming out. My name is Carmen Puccio. I'm a Principal Solutions Architect here at AWS. I'm joined with Mandis Momberg, who's also a Principal Solutions Architect, and Peter Hacht, who is a Senior Technical Evangelist at Dynatrace. I appreciate you guys coming out at lunchtime. Hopefully you find this talk interesting. So what we're going to talk about today is essentially how can you take your traditional application and move it towards a containerized workload, but specifically we're going to figure out how to break down a monolith, right? So when we start thinking about like mass migrations or any kind of migration, specifically like the legacy IT real estate, you run into these monolithic architectures, and a lot of people are trying to figure out how to move them over. And they want to take advantage of the cloud, they want to take advantage of things like containers and serverless, but they don't necessarily know how to break these things apart. So we're going to show you guys how to do that today. So we have quite a bit of slides, and then we're going to get into a demo, right? So to start it off, we'll just give you this nice little introduction. Here's the monolith, right? I'm not going to read this for you. This was from Wikipedia. But essentially, we all know what a monolith is, right? It's this tightly coupled thing. It sits inside your data center. It's probably been there for years. Your development teams probably don't even exist anymore, the people that originally built it. But you still want to move it, right? So it has pros and cons. And they're right here. So again, I'm not going to necessarily read these to you, but Mandis, who is our developer advocate, and he actually built the monolith, right? I'm going to ask him a question. It's like, Mandis.
Is this like a case study type
This is a case study type of thing, right?
We can do that.
So Mandis, so we have our example application, right? And it's our booking service. And I saw AWS personalize, and I want to be able to start making recommendations inside of it. How long would it take you to actually put something in place if we wanted it out by Christmas?
With our monolithic application, I mean, that's a great idea. We can predict and we can suggest some vacations to people. That's a good idea. I mean, we could get it out around the second half of 2019.
Yeah, but I need it in like the next 2 weeks. Why is it going to take so long?
Because it takes about 3 days to compile, and then we have to go through technical testing and those type of things. It takes us a while.
What happens if I get you more hardware?
We're kind of at the limit of vertical scaling right now, but we're told that in 6 years, quantum computing will be available, and then we'll be better.
So you get it, right? So there's all these challenges that come along with it, and you don't want to run into these things. You want to figure out how you can do this stuff quickly. You want to figure out how you can have all of these pieces broken apart and move at scale. Right? So that's what we're going to talk to you about today, right? So if you look at the development lifecycle, it's essentially the same thing, right? You have your developers, you have your monolith, they're still building, they're still testing, and they're still releasing code. The one thing that's tough here is everything's self-contained, the test process takes a really long time, and there's all these interdependent components, right? And we want to figure out how to break that so you can actually make this process quicker. So why should I migrate it, right? So before I get into the hows, right, we want to talk about things from the mass migration team because we feel that the principles that we learned from that team are relevant here as well, right? So Mandis and I both come from that team. We're also on the AWS container team. But what you're seeing here is our R's, right? So this is from Gartner. We've publicized this out a million times. And there's no right path here, right? We talk about the planning. We talk about the strategy. We talk about all the things that go into place to essentially moving workloads over at scale. And just because one path is shorter than the other, or at least it seems to be shorter, doesn't mean it's necessarily the best path, right? So we really want to attack it like in multiple phases. And that's what we do here. And over the course of like the last 2.5 years, we have this process. And this process, we call it our mental model. And we go from a point of evaluating what we have, planning it out, designing, migrating, and optimizing, right? So essentially, like, how do I understand what I have inside my data center? How do I understand what my monolith is doing? And how do I use that to kind of break it apart and come apart with a migration strategy to either pick it up, potentially as is, or how do I pick it up and maybe break out certain pieces and move it into a containerized workload? And then after I've done that, how do I optimize after the fact, right? So we're really going to focus on this discover and plan piece, right? So we really, really feel that before you move anything out of your data center and you move these applications over, you need to know every single thing that this application is doing. And it's not just from the CPU and memory and disk and network perspective. It's all the way down to the code. What's it interacting with? What's the latency like? Are things tightly coupled? Are things loosely coupled? Right? You really want to go into that level of detail. And there's tools that can help you do that. And that's what we're going to show you today. So these questions are universal. So whether you're going from on-premise monolith to containerized services to cloud native, right? You have to answer these questions before you even think about moving. You have to answer these questions even after you moved, right? So these are like, think of these as like your universal theme, right? So then this topic comes up. Should I consider containers as part of my strategy? People hear about this lift and shift, right? Pick things up, move it over. AWS is the server migration service. It allows you to pick your application up, basically in this mirror copy. Think of it as like a VM copy or a VM snapshot of your machine into AWS to an EC2 instance. But can you move your applications over to a container, right? And Mandus is going to give you a little bit about that.
Yeah, that's kind of interesting. You saw the 6 R's on the screen there where Carmen spoke about, and that's traditionally been lift and shift. We've spoken about rehost, right? And we've been kind of looking and talking about maybe adding a 7th one and maybe calling it something like refit, where you do a lot of the same steps that you would do in lift and shift without changing any of the code in your application and in your monolith, but you refit it and put it into a container because containers lend to that ability. So once you refit it, you put the monolithic application as it is and run it in the container, but that container, now that it has that shippable characteristic, allows you to achieve a couple of things that we think is core to success and is core to making that migration a true digital modernization of your business. And those core tenets are those things that make you more elastic, that helps you be highly available, but more specifically and most importantly, give you agility. So how do you get that from a container platform, right? In a container platform, just by adding that binary or that monolithic application into a container, you kind of accelerate the development because the time it takes for you to share the code, to mimic the code and the experience of that application inside of your developer environment and making sure that it has the unified experience in the production environment already accelerates. So you already immediately gain some agility in your business. It allows you to faster iterate on your application, make changes more quickly, even if it's still in that monolithic state. And if with that faster iteration and that easier adoption for your developers and your engineers, you can start breaking out that monolith a little bit faster. So the first step is get it into the container and then learn what your application is doing, right? Like you have to understand what's actually happening inside of your container. So we have many customers running containers on AWS. There's been a lot of resources and a lot of research done that shows that the most containers in the world are currently running on AWS. It's the perfect modularity for cloud computing when you talk about elasticity and agility and scaling and being able to scale down when it's required. But what does containers really, really give me? Like we've spoken a little bit about agility and it gives you that ability to iterate quickly, but why should I still do that? Because I can technically do that with a bunch of VMs. I can technically take my application package into an AMI and then run it on my VM. Well, the cost-saving opportunities in something like bin packing alone is worth investing in containers. Because you can now run multiple versions of the same application with different dependencies on the same host, it exponentially saves the effort and cost of your infrastructure. It also breaks down on effort because now once you build a container image that has the requirements or the basic requirements for something like app monitoring, security, audit, and compliance into what we call a container layer, your teams across all of your business units can consume that same layer and don't need to invest time in R&D and also building out that layer themselves. So you might have this initial investment where you might put some time into R&D for building those base layers, but once those layers are secured, they're inside of your security team's repositories, they're inside of your deployment repositories, accelerating development for your application engineers and for your product owners exponentially picks up, and that effort that you break down saves you cost, and obviously the simplification of maintenance through the orchestration layers that you use. Now, that's also where we as Amazon kind of stepped in and tried to make the orchestration of containers a lot easier for you. Because running a container on a developer's laptop, that's easy. I mean, you can do that in a couple of seconds, and there's some great tooling to do that. But running a container at scale with thousands of applications and thousands of containers across hundreds of hosts or thousands of hosts get complicated. So the deployment benefits that we want to do is we want to create an automated pipeline where we shift some of the responsibility of that application experience where the customer interacts with that application to the left of the pipeline where the developer sits. Now, we did something interesting at Amazon a couple of years ago when we were modernizing our business and when we were transforming and breaking down our monolith. Our monolith was called Obidos. You can look it up on Wikipedia. And we created something called cells, but today it's more commonly known as microservices. But we decided to give our developers the responsibility not only for the code of the application, but also the experience that the customers have running that application or working with that application. And we found something very interesting happening. We actually found our developers started writing better code. And they started writing code faster because none of the developers wanted to get paged at like 3 a.m. in the morning because the application went down due to bad code. So with containers, you can accelerate this ownership moving to the left and building out the resources inside of your code repository, securing it, checking it automatically in the pipelines, pushing it to something like an image repository in ECR, and then deploying it at scale across any of the variety of managed container services that we have. For example, we have Amazon ECS, and then we have Amazon Container Services for Kubernetes, which is our managed Kubernetes offering, also known as EKS, where you manage your EC2 infrastructure, but we manage the control plane for you. We manage all of the heavy lifting around making sure the orchestration itself works as expected, and we do all the security and in-place attachments and things like that for you. Then we have something called AWS Fargate, which is a subset of Amazon ECS, which not only manages the control plane for you, but also manages the worker nodes where your applications will be running. It's really this experience of, here's my application in a container, I give it to Amazon, run it, I don't care where. Just run it for me, I don't care where you're running it, I just want my application to run. And that just accelerates that deployment and that iteration and that agility that we spoke about a little bit earlier. So a modern development lifecycle actually happens in something we call a multi-lane highway deployment solution, where you have multiple developers working on the same applications at the same time, running through tests, building, testing, and releasing at the same time. You have to do it in a synchronous manner or an asynchronous manner at the same time with synchronous results. And that can be difficult, especially if you want to start integrating and making sure that you comply to things like PCI compliance, or even making sure that your security tests and CVEs and those type of things aren't being affected. So rolling deployments is one of the huge benefits that you have with containers. We've all done rolling deployments with EC2 instances. We've done it with on-premises. We've always got these convoluted playbooks and different tools where we have to retire and we have to drain connections and push out all of these things. And it's always a pain. It's never an easy thing. Containers have made it so much easier because you have this one idempotent module of shippability that is called a container. It sits in a very highly scalable, very active image repository, which is managed for you in Amazon called Amazon ECR. And that image gets deployed to hundreds of nodes automatically through the orchestration system. So service A can be set to do a certain desired count. So for basic deployment, if you know that you have an always running cluster that has a minimum requirement, you set that desired count as 4. But you can also then have 4 containers. And the system will make sure that if a container fails, that it gets replaced if something happens. But now you want to independently scale that as requests come up. So you enable autoscaling, and that will add more containers from that same image that you know will act exactly the same way when you deploy it into your cluster and scale requests across all of these new containers. So now that will make sure that when the minimum health capacity or the minimum healthy capacity is 75%, it basically just shrinks down and you have less containers inside of that environment, or it grows out as well if you need to. So that's a rolling deployment, right? So we basically make sure that we always have a certain amount of containers running. So we have a minimum health capacity of 75% containers running the latest version, and we replace in process without needing to switch over any of our deployment functions. We have Canary deployments, which is also a very common deployment where you do testing and the failures, and we can actually use our service Route 53 where it does health checks against certain endpoints, and if it detects a failure, automatically changes the DNS to another load balancer, and it connects to that new endpoint that we know is all available. And again, because we have the shippability in the container, we can deploy the application across multiple regions and not just availability zones. So you're no longer restricted by things like EBS volumes that only allow you to launch that same instance with the same image in the same availability zone. Now with a container, you can quite literally deploy your container in any region, flip over the DNS records, and have the same customer experience that they had in the failing region. So where do I start? Well, the first thing you have to do is you have to understand what your monolith is doing. We have this premise that you have to understand what you're doing, so investigate what you're doing, take one small step further, go forward, make one small change, reevaluate where you are, and then do that again, right? So it's figure out where I am, make a change, evaluate where I am again, and reiterate. And the best way to do that, or actually the only way to do that, is to use data. Because we all have a gut feeling of what to do, but we really need to have the data to tell us what our applications are doing. So our partners from Dynatrace really gives us the ability to introspect into discovering our workloads.
Yeah. Yeah, so to go one step further on that, right? Because again, you don't want to be interviewing people. You don't want to rely on CMDBs. They're decentralized. They're out of date. You don't have the metrics you need to essentially break this thing apart. It needs to be a data-driven result. So again, when we talked about portfolio discovery in the traditional sense, we would think about like the application owners, the environment. You would look at things like CPU. You would look at things like memory. You might want to start thinking about right sizing, things like that. That's the traditional way of thinking about portfolio data discovery. At the same time, you still need to think about the application connections. When you think about an application, specifically a monolith, you want to know all the pieces that are involved, right? So dependencies are super important, and you still want to start to think about the actual performance metrics, right? Service naming and tagging is very important as well, but really these things that you've seen on these prior two slides, these are helping you kind of get to a decision where you can figure out what to move first. But in the context of breaking up a monolith, which we're going to talk about in a second, this is just the starting point, right? You need to go much, much deeper than that, right? So again, here's just a couple of the partners that we work with in this space and some of the AWS tooling as well. We're here to talk a little bit about Dynatrace. We're going to let Dynatrace do their thing. But again, it needs to be a data-driven result. So if you want to get your application, you want to take that monolith and break it apart, start thinking about containers, and we're going to show you this in the demo, you need to use some sort of tool. And Dynatrace, in our case, this is the example, right? So with that said, I'm going to pass it to Peter.
Thanks, Carmen.
Yep.
Hi. So my name is Peter Hack. I'm with Dynatrace. And so the real question is, where do you start, right? So when we look at this, we have kind of broken this out that what can Dynatrace bring to the table? How does it help you to understand your applications? And so this is the first part. Dynatrace actually has a Smartscape, and the Smartscape will automatically discover all the dependencies that exist within your environment. So as those applications are talking to each other, Dynatrace has already instrumented them automatically. And through that, we're able to discover all of the different dependency maps that exist for those applications, how they're talking, what's most expensive, et cetera. So you're able to then, from that level, using the AI, we can analyze that and then use our automation API to help understand kind of if you're going to make these movements, if you're going to move things to, for instance, migrating into AWS, or you're already in AWS and you want to break things apart, understanding, is this talking to my RDS database? Am I using Lambda? If I want to use Lambda, how does that work? And can I understand the connections of those transactions? So better or worse during the transition. So this is kind of an example of our Smartscape. And as you can see, this is all auto-discovered. And what we're actually presenting to you in this view is understanding kind of the full stack of your application. So the service calls, the dependencies that exist in those service calls, for instance, the Tomcat instance in the middle, and all of the components that it relies upon, so all those dependencies, as well as on the left, understanding where it's running. Is it running on EC2 instances in your data center? And understanding how those relationships are. And at any layer of that, you can also see those dependencies. So which hosts are talking to which hosts, which processes are talking to which processes. So as an example of this, Landbay is a peer-to-peer lending company in the UK. And they did a full migration from the monolith, from their existing environments, directly into AWS. And they used Dynatrace to do this. And what was really important is because we gave that full breadth of understanding of their application stacks, of all the logging and all the details, they were able to very quickly migrate over in a matter of, I think it was like 6 weeks. I think it was like a 6-week adventure. There's actually you can go to our site and take a look at the case study on that as well. But all right, so let's talk about this monolith, right? We're talking about monoliths?
Yep.
All right. Yep. All right, so when we're looking at a monolith, this is kind of this is the block version of it, right? You have endpoints that are talking to your application, to your monolith. And from that inside, there's a lot of different services going on. And then those have dependent services outside of this, so calling databases, calling queues, calling, et cetera. So how does this work? Well, so one of the things that Dynatrace says is, well, we can break that out. So this, as you can see, is another kind of view of this, but this is from Dynatrace. So looking at a service, right, the monolith, this customer front end, we see the calling services that are coming in. We see all of the infrastructure that it lies on, so these 4 Tomcat instances below, as well as the host they're running on, and to the right, the dependencies that exist downstream. So being able to see all of these different components is really a key part of breaking up that monolith. So all of this data is discovered automatically, and Dynatrace, in addition to that, is also discovering your endpoints. So now you can also understand what's my load on these endpoints, which ones are my most expensive, what makes the most sense to break out into a monolith. So Dynatrace, in this case, is presenting a number of endpoints, detecting those endpoints and showing you detail about that. So then we could take what's called a service flow, and you can look at the service flow where my endpoints are communicating downstream to other services. In this case, looking at I have my front end, which is my monolith, talking to back end services. And you'll see that we can see the execution flow, how often it's called, how tightly coupled these services are. And this gives us a lot of insight into what's going on in the environment itself. To take that a little further, right, if we look at it from the dependency map, we really get a true understanding of the dependencies of all of the calls that are being made from that service, right? So it's not just my service calls another service downstream. It calls a number of other services downstream. And being able to understand those patterns, and those call patterns have specific loads and how tightly coupled each of those services are, Dynatrace can expose all that for you through that service flow for each endpoint. All right, so what we learned? Well, we have a service, and this is through Dynatrace able to discover for you what that monolith looks like inside. I see all of my endpoints. They're talking into Dynatrace, or talking into your monolith, and Dynatrace has helped you to discover how those paths go, what all those patterns look like. So this can help you then to discover which monolith I should break apart. Is it a problematic one I have a lot of errors on? Is it something that consumes a lot of CPU? Maybe I want to move that out, or are they tightly coupled services? So when we do this, we kind of break this apart by the entry points. So this is actually something I'm going to demonstrate in the demo, but what are your entry points inside the service? Those entry points represent all of the different service-oriented architecture built into your monolith that you now want to break out into components that can be put into containers and deployed in an idempotent way outside of the service, right? So outside of that monolith, built separately, tested separately, inside of your pipeline. So how do we do this? Well, first, let's look at that endpoint and figure out which methods, which classes we're actually using as our entry point, which ones are the most expensive. So we find an entry point that we want to package up. And within that, we create rules around that entry point. So anytime I see this entry point, this class, this method, I want to use that as a virtual service. So within my monolith, without touching any code whatsoever, Dynatrace is providing you the ability to virtually break apart your monolith. And in doing so, you then are able to see that we can now choose those different entry points. Now, the entry points here could have already been automatically discovered and displayed as services, but at this point, I can choose maybe it's my journey or my booking that I want to move it out as a separate service, because those are things that I'm seeing either a lot of problems with, or they're more likely, they're a better candidate, for instance, to be in a container running in a more accelerated development cycle. So then we essentially can refactor this, and we can show, as we work through the service, through the service flow, we can actually understand, are things tightly coupled? Is this actually a good candidate? If something is talking 100% to each other, one service is talking to another service inside the monolith at 100% of the time, do I really want to break it apart because now I'm moving out of in-memory communication to network-based communication, container-container. And that could actually introduce latencies and things like that we don't want to. So this Dynatrace is giving you the ability to choose in an intelligent way through the data of what is the right piece to break apart. Of course, afterwards, we can also show you the performance of that service beforehand and after. So as you make those changes, Dynatrace can help you to balance and actually compare the performance before and after. And if we have a lot of errors, if there's increased CPU consumption, we want to be able to present that to you as well. And in addition, from the container monitoring, in addition to our AWS integration that we can provide a lot of details on, we also can see and auto-discover all of the containerized applications themselves and be able to show service monitoring within those containers also, with also no changes to your code or your images. You don't have to rebuild your images with an agent or anything. It's all part of the OneAgent that Dynatrace provides. And actually, in the demo, we'll go through a little bit of this.
Right, so by a quick show of hands, how many of the people in the audience actually have been working with containers and are familiar with containers? Okay, so
Good.
At least most of the people here know what a Docker file is and how a Docker image works. Great, because we do speak about it, and we show it in the video. Okay, so let's kick off this video. The first portion is basically just the discovery. There we go.
Great. So this video is going to go fast, so follow along. we're installing the OneAgent. How do you do it? Well, with an EC2 instance, it's actually quite easy. We just grab our Linux installer data, put it into the user data of your EC2 instance, and then when you deploy that instance, it'll automatically come up with the agent installed. So then we can automatically present that data to you as well.
So what is the OneAgent?
Oh, sorry. Yeah, so for those of you not familiar with Dynatrace, we have a single agent that you install into the nodes where your applications are running, in this case, an EC2 instance. But we also support, through the OneAgent, a number of other technologies and containers and otherwise. The value of this, though, is it covers all of the technologies, Java, PHP, .NET, Node.js, et cetera. So through doing this model, you can do the monolith whether it is any of those application technologies.
Okay.
Okay, so we have all the specific metric data around our host. That's all automatically discovered out of the OneAgent. But in addition to that, we're also able to discover all the processes that are running on that host. And for .NET, Java, et cetera, we're automatically able to instrument them as well. So we see we have this front end. This is my front end is my monolith. And we're going to start exploring that data. So we look at the specific host. We look at the front end monolith data here. And we're able to discover all the endpoints, all of the metrics, the response times, request data, et cetera. All of the service dependencies that exist between the different calls to this service as well, or this process as well as out. And the service layer below, we're able to see the specific services that we want to present. Then, of course, all of this data is presented as well in the Smartscape. Now, the Smartscape is a pretty picture, but there's a lot going on here. And we can present to you all of the stack data, understanding top to bottom where my applications are running, what service endpoints are exposed, what processes they're running on which hosts and which data centers. And all of this is automatically discovered by that OneAgent as well. So when we look specifically at a particular Tomcat, I have a full stack view of that Tomcat instance, as well as all of the dependencies that exist for that Tomcat instance specifically. In this case, my front end. So this is my monolith. So what are we going to do? When we look at this particular monolith, I have my, as you saw earlier, my incoming service calls, my outgoing service calls, and I can look at all of the requests for this particular monolith. And in that, I'm looking down at all of the expensive queries that are going on, or the URIs that are coming in, as well as my service flow. So now in my service flow, I can see that I have these 4 back-end monolith services that I'm talking to, or back-end services. And in those back-end services, they have we have other service flow dependencies existing, and we can see calls down to present the database, et cetera. But in this case, we're going to kind of virtually break up that monolith, right, using those custom services we talked about before. So it's all inside the UI. You're not changing anything in your code. All you're doing is we have some rules that we defined already, but we're going to kind of walk through one of these rules. And essentially, what I've done is I've defined the booking bean that is my entry point here, and I have a method that I'm using as that trigger. So Dynatrace automatically will see that trigger, and now instead of 4 services that I'm dependent on, I now have 6. So the 6, the 2 that were added were the 2 custom services I added in, which are my front-end booking and my front-end journey, right? So those 2 are actually still in my monolith, but I'm now treating them as a completely separate service. Let's see where this goes. So now, okay, so when we look down at the service flow, what you see now is it still has 4, but there's actually 3 services that really aren't contributing a lot. So we're showing the most contributions at the top. But in this case, you can see my front-end monolith on either side here. Sorry, you can see my front-end monolith being presented. And now I can actually filter just for that in the service flow. So now I can see across this that my front-end monolith then calls my back-end, right? So my front-end booking calls the back. So in this, now I have a really good understanding of what's going on in my monolith. All right, so what do we do next? Well,
we want to put it in a container. We want to run it in Fargate. So remember, Fargate is our completely serverless container service. So you take the image and you just give it to Fargate, and Fargate runs it on our managed nodes. So you can imagine that in that situation, you cannot take the OneAgent and install it on the EC2 host because you don't have access to the EC2 hosts. So we have to take the OneAgent and put the OneAgent into our container image. And because container images allow us to do that, and that's how the technology works, it's not very difficult. It really starts off with adding the OneAgent from a layer that we've already created, that our security team have signed off on from before, and put that into our existing Docker file definition, and then using that to execute the launch process of our application. So basically our entry point. So right here, you can see that. So at the left-hand side of the screen, you can see me building the application stack. Now, we have the full stack. Here you can see where we've broken out all of the different discovered services. So we've got the back end, we've got the front end, we have all of the different services and the different layers that we discovered using the Dynatrace tool, and we created something called the Docker Compose file. So this Docker Compose file allows us to immutably provide infrastructure to all of our developers so that when they develop their application and test their application, they can always bring up the same services in exactly the same manner. So Carmen can work on this product, I can work on this product, anybody else can work at this product at the same time individually on our laptops and make changes and be sure that all of us have the same experience and that the changes that we make will affect the overall project in the same manner. So in our definition, we define all of our services like the back-end service, the front-end service, but we also want to make sure that now that we've containerized our application, it also acts and experiences the same performance or even better performance than it did before it was containerized. And therefore, we need to also do monitoring on it. And the way we do that is inside of that definition, we provide the command that allows us to execute the OneAgent. And the OneAgent, it's a simple override command like that inside of our container. We don't need to make a change to our code. We don't need to make significant changes to our Docker file. We just add this command, and we have this command run our initial start process. That will invoke the actual Dynatrace OneAgent inside of our container and keep track of the process that it was launching and monitor and report to that monitoring. Once that image has been compiled and this image has been built, we can then upload it to our container registry. So you can see here, for example, me creating the new container registry for our backend service. That will allow me to now log into our ECR system. So for those who's never used ECR, who's never used Amazon ECR? So Amazon ECR is a fully compliant OCI container registry, and we've just added some security levels on top of it to integrate natively with AWS IAM. And the way that you log into it is very simply the same way you log into any system with the Docker login command. And we've made that even a little bit easier by integrating that to our AWS CLI tools. So here you can see me logging in and authenticating using the AWS CLI tools. There it logs in, and you can see it's succeeded. And now I can take the repository URI, the actual repository name of the new repository I created, and I can tag my local images with it. Once I've tagged my local images with it, I can upload that image into ECR and then pull it and deploy it into Fargate. So I've listed all of the images that I built. There you can see I select the latest image ID using the normal Docker commands, and I tag it with my remote repository. I'm going to do another list just to show that the tag actually has been applied. And now I can do a very simple Docker push. So it's Docker images push, and there we go. So that'll upload all of the layers. Now the nice thing is, in ECR, we only upload the layers that we don't already have. So you'll see that there's actually a discrepancy in size from what it shows on your local host and what it actually stores for you in ECR, because many of these are things like CentOS layers and those type of things that are shared images that we don't need to bill you for. So once you have it in ECR, you now have the ability to seamlessly add that to a task definition in Fargate, which you'll see in just a second, and we can deploy the application through that. Now, one of the great features of ECR is that we have something called a lifecycle policy. So for those who are familiar with AWS S3, you know that you can actually retire objects after a certain amount of time, or if a certain version has been extended. So the same thing happens with ECR. If you do a high number of releases and have a high cadence of building images and pushing it to ECR, which we expect you will if you are doing it in an automated fashion, you can have lifecycle policies that will automatically retire and delete images that are older than a specific time that you set, and clean out that repository to make sure that you're not wasting money on irrelevant images that you no longer need. So now that the Fargate cluster, we've deployed our application into the Fargate cluster, it's running on a completely managed environment, completely obfuscated, your container is just running, you don't care about the nodes, you don't care about the cluster, you just care about the actual application performance. We go back to the Dynatrace console, and we now monitor this new application that's running in the ECS Fargate cluster and see how it's acting as opposed to when it was running on an EC2 instance.
Thanks a lot, Mandis. So yeah, so now, because Mandis put the OneAgent into his container, so it's automatically deployed, Dynatrace is you can see it's seamless. We don't treat it differently than the original services you were looking at before. So we see this process running, we see the services that exposed, and you'll see that now we have this Lambda, or sorry, this Fargate front end and back end as well. And those, if you notice, these services, there's 6 services again. And the reason is because Dynatrace already has the entry point and the method, so we've already, since those rules exist, Dynatrace will apply it to these as well. So now in Fargate, we see across, again, the service flow that you were familiar with before, and we can see the performance. And what you'll also notice, though, is that the Fargate, the second one down there, that Fargate namespace, was listed actually without a proxy because it's still in the same container or otherwise. So in this case, we're looking now at a dashboard. We can create dashboards on CPU utilization, memory utilization, just general quality and uptime. So ultimately, though, when we do this, we want to know which is better, right? So which did we get better performance? So we have lots of different ways to compare this. We could look at this from, we have something called management zone, so we can look at all of my Fargate or all of my EC2 monolith-based applications through this filtering. But I can also filter specifically maybe for a specific type of service. So maybe I want to look only for my booking service and say, from my booking service, how did it perform before? How does it perform now? Which is better? Is it my Fargate or is it my Monolith? Which one's performing better? So in this case, we see a little bit of an imbalance going on there. But in either of these, I can look and understand kind of the behaviors in a number of different ways. I can do comparisons straight out of charting right off the screen. This happens to be load, so I'm showing load distribution. But you could also look at, for instance, CPU response time or et cetera. So all of these pieces can be built into a list of charts. And those charts can very easily be brought into your dashboard. So you can see, again, a comparison of the race, right? Which is my EC2 instance better running with the Monolith, or is it better in Fargate? I can also see the distribution, as well as my throughput and things like that. So these are different ways for you to expose this information. And then be able to say, OK, well, it is not running as well, or I'm running very slowly. Why? So now Dynatrace allows you to dig down into this and look specifically at, for instance, the hotspots. Is it the calls that I'm making? Is it my database queries? Is it the code execution? So in looking at this, looking at the hotspots of the code execution, I can identify very quickly what's most expensive to me, which methods, which classes I'm spending the most time. And this is essentially what Dynatrace can provide for this particular use case. There's a number of other use cases, of course, but what Dynatrace can provide to you if you're in this monolith journey.
So that's fantastic, because now we have data-driven information that tells us about what our application's doing. I touched on this very quickly and very highly just before I started the demo, or just before we started the demo, about the value of iteration. Now, the idea of iteration through modernization is not a significantly new idea. We've been advocating this for many years, and we've always said that you should fail fast. Make that mistake early on in your development experience, fail fast, iterate, and get to your customers with the right answers, and make your customer experience better, and don't be afraid of failure. But it's a difficult thing to do. How many of you know about iteration and failing without fear, but have actually achieved it by a show of hands? Maybe 1 or 2 people in this room, right? It's very difficult, especially if you're taking from an environment where you're running a monolithic application on an on-premises enterprise-grade environment. And how do you get to this point where you fail without fear? And with this data-driven information and being able to monitor your stack, know what your customers are doing, what the customer experience is, and through the container technologies and automation that you've put in place, you can now more easily iterate on that design. You can now more easily go and say, well, my customers are having a bad experience when we load the page, right? When they go to our homepage and we try to do a listing on all of the orders or all of the available travel options that they have, our application is going slowly. And you can use this data, inspect that data, see to the code level where the bottleneck is. And using your automation and container technologies, you can make the changes and execute those changes into your production environment in a very short amount of time. We have a customer that is one of the leading examples of how an enterprise-grade customer that is 106 years old, they have literally been around before the invention of the microchip. They used to be around when stagecoaches was running around the country, right? They're 106 years old, and they were able to modernize their business to the point where they conceptualized a new product for the people that was using the customers that were using their business tools, and get that new conceptualized product into the production environment and into the hands of those customers within 6 weeks. 6 weeks. They came up with the idea, they had the idea, they built the idea with their developers, they iterated, and they got it into the hands of their customers within 6 weeks. Along the line, they failed. Along the line, they made mistakes. But they iterated, and they made sure that their business logic, their application, was still in compliance with PCI, was still in compliance with all of the regulations and the rules that they needed to follow in the area that they're working with. So how many of the customers in the room today actually are working in a regulated industry? Yep, that's kind of something we expect to see. So how can Dynatrace actually help customers in a regulated industry?
So there's a number of ways we can do this. So we have, in some regulated industries, it's about retention. So if you need to retain your data for periods of time, you have the opportunity to do an on-prem deployment as opposed to SaaS. So Dynatrace can work in either, bimodal in either way. So if you have regulatory issues where you need to understand, for instance, transactionally what's going on between users, we can present that as well and store that data out for you as well.
Okay. So Carmen, I know that you have an experience with using AWS native services in your previous life before you joined AWS. Yeah. And I know that you always talk to me about how if containers were really around back then, now your life would be a lot easier. Yeah. Can you kind of tell the audience what you've always been telling me?
Yeah, absolutely. So like when we used to think about like our migration, and this was something that we were working on as part of the mass migration team, we were thinking about it in this lift and shift model, right? So we were basically picking up our applications, placing them down. We didn't necessarily have that flexibility, right? So if there was a code change, it was still, very much around those principles of manual deployment. We might have been doing some sort of blue-green testing around cutovers, but then we learned, right? It was more along the lines of like, how can we actually do this and fail fast, like Mandis was talking about. We eventually got to the point where we were thinking about how can we do things at the configuration management level, but in a way that's still kind of treating those applications like cattle. I'm sorry, like pets and not cattle, right? And that's the way that we wanted to eventually go, right? But containers weren't as popular back then, and at the same time, too, I don't think that the technology surrounding it was as prevalent, right? So when we talk about, like, how can you migrate your applications at scale, how can you break these monoliths apart, this is the kind of stuff that Dynatrace and containers together enable, right? And we didn't have that capability back then. Again, we're only talking about 4 years ago, right? It's amazing how quickly it's evolved in the last 4 years.
Yeah,
right?
container technologies are relatively new in the industry, but they've had a big impact, and they're really making that transformation journey a lot easier. When we talk containers, we always say that containers alone is not the solution. Containers alone really gives you the ability to make portable applications, but at scale and truly transforming a business isn't very easy with only containers. You have to think about orchestration. You have to think about everything that goes with it. So how many people in the room think they have a good DevOps practice in their business or an SRE practice in their business? I mean, it's not a trick question. You can answer if you think that you are. But we usually challenge that when people say, yes, we have DevOps in our business, right? And we challenge that and we say, well, at any point in your DevOps practice, when a developer pushes code to his repository, does he or she have to wait for a manual intervention from something like a security team or a compliance team? Or at any point, is there a manual intervention where a human needs to get involved in the process? If the answer is yes, then we challenge and say that that DevOps practice might not be as effective as you think. And the reason for that is that through all of the data that we've gathered and through all of the experience that we've had with our customers, we have found that humans tend to be the most error-prone fact checkers and health checkers inside of the business. If your application tests are written in the correct way and your business tests are written in the correct way, it accelerates you to get your product to your customers faster and then helps you focus on things like saving money on infrastructure, iterating on your application builds, iterating on the actual performance of your application. And when we bring up the business owners writing tests, we always see a lot of people sit back and they listen up a little bit and they think, well, how does that work? How do we actually have our business owners, the people that own the product and want to understand and own the customer experience of that product, how do we have them write tests? They're not technical. They're not the people that actually know how to write code. And well, we have a couple of customers that have done this. They literally had their product owners take some customers out, have them record things like sessions on a web browser and a WebKit browser, and they took that data and tracked that data around how every click has happened and how long it took for it to respond and what the customer experience was. And then they replay that in automated tests as business tests. And if those fail and push back, then they take things like Dynatrace and they look, why did this happen? Why did this response take longer? And then they find, oh, well, this time, instead of using a recursive step function for us to go into the data, we used the for loop, and that just pushed up our CPU usage, and therefore everything just basically became a bottleneck at the back, right? So remove those human errors, remove those human interventions, and also make sure that the trust in your business and the culture in your business changes to a point where the developers can actually work with the security team as a unified team. The security team should never be the stopper or the blocking point for your business. We get too many customers come to us and say, we have created these fantastic containers, we have these pipelines using fantastic tools, and we've integrated monitoring, and we've built this application within 3 weeks, but our security team has taken 6 months to review it, and they still don't know whether they can whitelist it or not. It's not a great experience for your developers, and it's at that point where the developers sit around playing with Counter-Strike Go or something at work because they are compiling the kernel at the back end, right? It's not a great experience. It demotivates them. Another thing in the culture, and this is something that we at Amazon kind of do, and I think I've spoken to the Dynatrace team as well, is like we really celebrate failure. We celebrate failure. We have this internal thing of where we award people using something called the phone tool icon. And we actually celebrate that if you find a bug inside of like any of our products that we've created on the launch day or before launch day or through beta testing, if you find something like that or if you make a product fail, we actually celebrate that and you get a phone tool icon. It's a badge of honor to say that you found this. And we want people to find these bugs before they go to market, before they get into the hands of customers. Because rather than let them fail for us and be able to iterate quickly and fix that failure and get a good product out to our customers, then the other way around. We don't want to invest 6 to 8 months with no testing or with no experience testing and not failing because we're afraid to fail. Right? We celebrate failure. We change the way that we goal our engineers, our developers, our SRE engineers, the people that our product owners work with. We change the way that we goal and what their success looks like. We're not tracking them on the amount of lines of code they write. We track them on the amount of features that they were able to improve the customer experience, to minimize the CPU usage, those type of things. Because we were able to look at the data and work backwards from the data and say, these are the places we can improve on to make our customer experiences better. And because we've put in place all of this automation, because we've broken it down to microservices, we were able to iterate and implement those changes a lot faster.
Yeah. All right, so with that said, I think, like, again, the key point or the key takeaway here, right, is before you break this thing apart or before you think about moving any application, right, you need this kind of data to make a data-driven decision, right? You're not just going to guess. You're not just going to kind of just pick things up willy-nilly. You really have to make an educated decision about where you're going to basically pick the thing apart and then move it and then iterate on it after you move. And again, things like Dynatrace and then container technologies really help you in that space, right? So when we talk about this lift and shift mentality, when we talk about, you know, moving applications over, if you have this kind of data in the beginning of your project, it should allow you to theoretically break these monoliths apart, right? Again, there's obviously going to be code changes that are needed, and you're going to try and move the application over, and you might see failure, like you said. But because it's sitting inside of a container now, that's great. You know what? As long as you have test plans in place, it should fail. You shouldn't impact your customers, and you should be able to iterate upon that and eventually get to a part where everybody's happy, right? So if I come back to Mandis next year, if we've potentially broken this thing apart, and I say to Mandis, hey, you know what? I want to put this new personalized service or this new personalized functionality in place. How long is it going to take me now?
A couple of hours.
That's the hope, right? That's where you want to be, right?
It depends on my skills in Ruby.
Yeah, we're going to do it in Ruby? Okay.
We'll do it in Ruby.
Yeah, all right, perfect. So, but that's the kind of stuff that you really want to think about. So again, there's a lot of theoretical pieces here, but the one thing that is not theoretical is you can't do this without having data, right? And this is what they're bringing to the table. And that's hopefully what we tried to instill with you guys today, right?
I think our core message today is that breaking down the monolith is something that everybody has been thinking of. There's a lot of resources out there that constantly talks about the things you should be doing when you break down the monolith. And there's a lot of resources about how you should be running containers. But the truth is, none of that happens if you don't know what your application's doing, if you don't know what your application performance looks like. You need to gather that data before you go down this journey. So if you don't take away anything from this session other than that, to know that you need to go and find the data and how to look at that data and where to get that data, then I'd be happy.
Yeah, awesome. All right, so with that said, I mean, I appreciate you guys coming out again. I know it's lunchtime. There are some related breakouts this week. And again, you know, these are in the past, but everything should be up on YouTube and SlideShare. So if you want to check them out, they should be up there by now because it's, you know, Thursday. But other than that, again, thank you for your time. I hope you learned something today, and have a great conference. All right?
Thank you, guys.
Thank you.